Do you like optical illusions? Or have you ever heard of the missing square puzzle? If not, I'm Hiba, and today we're gonna discover it together. Up here, a triangle appears that contains 4 pieces, 2 triangles and 2 other shapes. But wait! If I just exchange the place of the red and the blue triangle, just like them. Suddenly, we've got a missing square puzzle. How can that be possible? So to understand it well, we're gonna do an experiment in real life. But instead of missing a square, we're gonna have an extra square at the end. Up here, I have this bar of chocolate that I'm gonna cut right now. It will be just in this way. If I just rearrange these pieces just like that, we will have the same bar of chocolate, or nearly the same, but it will actually be missing one square that I can take away. Maybe things are getting difficult for you, but don't worry, it will all be clear soon. The solution to the mystery of why there is a missing square in the rearranged triangle is the fact that these figures aren't really triangles as we thought, because what appears to be the hypotenuse is actually a bent line, so the hypotenuse does not uphold a coherent slope. Well, you're not convinced, right? Let me show it to you. If you just count the squares that form the triangle, we're gonna have 32 as the total of the area. But if we apply the formula base times height divided by 2, we're gonna have 32.5. That means this isn't really a triangle, but a quadrilateral. And let's look more closely at each piece, and then we will find out that the blue triangle has a ratio of 2.5, while the red triangle has a ratio of 2.66. And as we all know, we can't have different ratios on the same line, so it's not really linear. So what creates the missing square puzzle in the rearranged triangle is the fact that what we can call the hypotenuse of the first one is bent inwards, while the hypotenuse of the second one is bent outwards. So the missing square puzzle is just an illusion based on the agent of concavity and convexity that was discovered by an amateur magician named Carey. That was tricky, wasn't it? Finally, not everything we see is real, even in geometry. Illusions are around us all the time. Oh, time! Here's another illusion.